Hello, my name is Gary Jones, and I'm one of the editors for Kit Planes magazine. In this segment, we're going to address the assembly of the fuselage for my personal Glasair. This is the Super 2 FT. The FT is the designation for the fixed-geared version of the Glasair. With that, we're going to do our best to video as much of this fuselage construction as we can to help you, the builder, have some insight as to what you're up against. And as we progress here, we're going to go from a bunch of airplane pieces to something that looks a lot more like an airplane. So with that, we'll go ahead and get started.
Here we have the right side of the fuselage. It's laying on the side on some sawhorses in my workshop. This area here that's roughed up is one of the forward attach points where we're going to put in some reinforcements. This particular reinforcement requires 4 layers of laminate, and and it's a large area, so I've used a template to help me in cutting out the cloth in the right size. Here's another laminate that's going to have to be done, and here we've got 2 layers that's quite large, and we've got, I think, 6 little ones that stack up on top of it. Again, this is for the wing attach point. This is the cutout for the rear window, and we're moving along to the back. That area there that's roughed up is for the horizontal stabilizer reinforcement. And again, because these areas are rather large, I went ahead and made myself a template. That worked out quite well. Now we'll go ahead and laminate these areas. Well, we're about to get ready to do this forward laminate for the wing attach points. Let's see here. One nice thing too, when these little popsicle sticks, if you knock off the rounded part and make them flat, you'll be able to scrape the bottom of your cup a whole lot better. And I think you get more use out of your stick that way, and the solution, the epoxy here that we're stirring up, gets moved around a whole lot better. I've got this laminate laying on a piece of plastic. I'm just going to go ahead and pour this epoxy out. It's about 60 degrees out here today, so I've mixed this epoxy up to 1.5% catalyst. We'll see how that works out and if I'm able to keep up with it. This is a pretty good size layup here. So I've mixed up 50 grams worth of goop, and we'll see if that's adequate. Notice how the plastic is holding my cloth in place, by and large. I'm not having to chase it. This is, I've put on an abundant amount right here because remember we've got 4 layers, and I want to get it pretty well gooped so it will saturate on up into the other layers that are going to go on top of this. Layer number 2, we're looking for a total of 4. You can see how the epoxy is coming up through the cloth. You know, 50 may not be enough here. We'll see what happens. Going ahead and using the stippling effect here with my little brush to help draw the epoxy up from the bottom layer to the second one. I've already put a layer of epoxy here on this area that's all outlined by red. Now I take my cloth on plastic and I lay it right where it needs to go. Remember, the plastic is on here
I choose to, I can leave the plastic on or I can take it off. I am going to take it off, however. But I just find using the plastic works very, very well in moving and working with fiberglass, especially this bidirectional stuff, because it just will dance all over. In essence, we're done here now. What I'm looking for is any kind of bubbles that might be about. Looks pretty good. That looks a little dry right there. I'll put a little extra on it. But this works out well to use the plastic, I think. You struggle with it and decide for yourself, but this has worked out very well in the past for me. Now I'll just go ahead and get rid of the bubbles, and I'm through with that layup. This particular layup took, if you remember, I mixed up a batch of 50 and it was not enough. Actually, it took about 75. Here I'm still working the bubbles out. There's different ways of doing it. I don't know if you can see it here or not, but I've got one right in front of my brush and I'm stippling it toward the outside, or toward the outboard edge here of where the fiberglass is, and it just squirts on out. I think we're looking pretty good here. Here's a nice big bubble. Plans also call for this laminate to go down to the roving, and this is the darker colored part in the fuselage mold. These areas I thought were kind of light in epoxy are starting to get the resin from the layers underneath, so I didn't have to add any to it. You can use the squeegee for this too. I kind of use a combination of both. Right now I've kind of already done the squeegee trick. What I'm doing here is just trying to get the bubbles out. This is a pretty good area here. It's probably 18 inches long at least, maybe 20, and probably 8 inches across here and at least 14 inches at the bottom. So we've got a pretty good surface area here that we're working with. This is why it took so much epoxy. This here is 6 layers of glass, also cut at a 45-degree angle, and it's in place. I just laid it here where I wanted it with my plastic, stippled it out, moved the plastic, and we're in business. Got 2 layers to go here where it's outlined in red. This probably should seem obvious, but when you're doing a pretty good sized layup, like the one I had just done and this guy here, make sure that you have enough promoted resin already mixed up, and make sure that you have your little catalyst jar filled up, because I'll tell you what, I got into a layup a time ago when I did the leading edge of my horizontal stabilizer where I ran out of promoted resins. And so I had to take the time to mix all that stuff up, and a little planning goes a long way. I really thought I had enough, but I didn't. This here's a little dry here on the edge, as you can see at the end of my brush, but this is also beyond where the roving is at. In another hour or so, I'm going to come out here with a razor knife and trim this while it's in the green state anyway. Also, Glasair has gone out of their way to outline this area in red for this 2-layer laminate, and this one here is kind of a semicircle in black. Stay within the lines. If you've got cloth sticking out beyond the line, cut it off, because all you're going to do is add weight to the airplane. And you have to be weight conscious with these airplanes from the time you open the box until you put gas in the tank. Otherwise, you're going to blow your socks off when you realize how much this airplane weighs. And if you're going to get, if you hope to get any kind of performance like that's advertised, you have to keep your weight down. This is just one way. You wouldn't think a little bit, like I'm going to trim this here in just a moment, would mount to much, and in reality it doesn't, but you add that up over the entire construction of the airplane and you could be 5-6 pounds, who knows. All the laminates are done for the reinforcement areas that is spelled out in the plans for the right fuselage shell. What I'm going to do next now is do these same laminates on the left side, and then when we video again we'll address putting in the antenna that goes in the right hand side fuselage shell in a vertical fin. To let you know, I went through about an excess of 200 grams of resins to do these 3 layups. and it took less than an hour to do the layups. Now, I spent quite a little time out here in the shop the other night cutting out all the fabric. So with that, we'll call it an evening, and we'll talk to you next time.
Oh, okay. Well, what we're doing is putting the coaxial cable on an antenna, and we have these ferrite beads, toroids, and you want to put them on before you strip anything, because once you strip it, then this stuff swells up and then it makes it really difficult to get them on. There's a shielding around the outside that is one lead, and then on the inside, which I shall strip in momentarily, and I'll show you that will be the other lead. And then we'll solder the respective leads to both poles of the dipole antenna.
What my friend Jim Patterson's doing now is getting the copper, putting a little solder on the copper here to accept the antenna. The copper foil has been hot glued down, and then when Jim gets through, everything is cooled off, we'll put a layer of fiberglass over the strips to hold everything in place. What we've done too, we've tinned the both the braided wire and the core of the cable, and also put some solder on the copper foil.
Ta-da!
We're all done.
Says okay, we'll check the only here. What's the deal here? Yeah, it's way it's screwed up, right? There we go.
Here we go. Jim's put the toroids in position, and we've got the hot glue gun heating up, and we're just going to put some hot glue there to hold them in place.
These toroids are placed on here to prevent feedback from the antenna and other electrical systems, so that we have a clean output on the antenna. One toroid cuts out 90% or 95% of the feedback, and this one cuts out 95% of that, and this one cuts out 95% of the total. So we're down to almost an unmeasurable amount of feedback that can come in. This works really well in the past.
Yes, and Jim's installed most of the antennas here for half the EAH chapter, and I can tell you with 450 hours on my Q200 flying coast to coast, these little copper antennas work excellent, both in the comm and the nav. They're tough to beat, and they weigh nothing.
What we're doing here is checking for continuity. This is something you don't want at this stage. You do not want these dipoles, and we don't have it. We don't want them to be connected electrically. And later on, when they're hooked into the radio, they will be, but at every stage there, as the cable, they are two separate pieces of wire, and you do not, under any circumstances, want them to be connected. And that's what we're just checking for right now.
Go ahead. Here Jim's using the hot glue gun to secure the toroids so they don't get loose on us. They're spaced apart about,
one toroid width is basically what they're supposed to be.
even if you use the Glasair's kit with the adhesive backing, I wouldn't rely 100% on that adhesive backing. I would at least tack it down a few places with one layer of glass. Better safe than sorry.
Let it cool down.
The antenna's been put in, and what we've got now, it's already been glassed down with just one layer of fiberglass cloth. There are a few things for the kit plane builder that's more visually
exciting or motivating than putting the fuselage together. I don't know what there is about it, but it's something when the fuselage goes together, you really have a piece that looks like an airplane. Your neighbors will stop by and your friends will, and they will be able to recognize a little bit of what you've been telling them all along is in fact true. Where I'm at right now is just in the basic phases of jigging the fuselage shells. You'll find that for the most part the shells go together pretty well with minimal jigging in most areas. Some areas require a little bit more. We're going to talk about some of these things and also talk about some of the tricks of the trade, if you will. Not that I know all of them, but I know some that will help you when you have things that just don't line up quite right. Let me say this right off the top. If you're struggling with a piece and it's not fitting together right, there's something wrong. And you're just going to have to slow down, take a look, and analyze what, for example, the problems are. In this particular thing, right now, as we said this evening, the fuselage is ready to be flipped upside down, where we're going to run the plumb bob in the vertical fin, making sure that the fin is in fact straight up and down. But for tonight, we'll go ahead and talk about some of the things about jigging. To give you an idea of how I got started with jigging these fuselage shells together was this. The first thing, I took the paper template that's supplied with the plans for the firewall cutout. I made it out of 1/2-inch plywood, and I was able to slide both the left and right fuselage shells in the wooden template that I have. And it'll fit around the perimeter of the flange where the cowling is one day going to be bolted on. This gives you a start. You've got to start someplace, and that's as good as any, and that'll keep the airplane from twisting and falling down to the fuselage shells, that is. It's not a bad idea to get a couple of extra hands, or not a couple, but at least one other person, and this part will go along pretty smoothly. I am at this point doing the basic jigging. I probably have 6 hours in it. But right from the onset, they tell you about how everything you do is going to affect the next thing that's in sequence here for the plan. This kind of precept upon precept. We just take our time and do it right. With that, we'll go ahead and we'll look at the firewall where the template is. We'll kind of work our way back, and we'll point out a few things that might be of critical interest to you during this phase. Okay, here we have the right and left fuselage halves shoved in the template that I had just talked about. Now, they talk about using a hot glue gun, and yes, in some areas that has the strength to hold things the way they should be held. However, oftentimes, when you need more of a grip for whatever reason, I would definitely use a Bondo or some type of a body filler. Along that same line of reasoning, they talk about using tape, like duct tape, to tape things together. I never use that because I found that the tape really didn't do the job that needed to be done. Also, that's addressed in here is using popsicle sticks. Popsicle sticks are okay if things are fitting together absolutely perfect. They'll have the strength that's needed to hold things in alignment. But if you have to put any kind of force or what have you on these sticks to hold things in alignment, they will eventually pop loose from the hot glue. So consequently, you'll see later that I've used something a little more significant than that. I've cut some strips of wood that are 1/4 inch, and well, the wood to begin with was a 1/4 inch in thickness, and then I cut it in the length and width that I chose that would do the job. One thing about it, when it comes to jigging, you become quite ingenious. You know, necessity is the mother of invention. Here, for example, I've used a C-clamp and a piece of wood to clamp together this particular area. These pieces of wood here you might recognize as being the jig, or the fixture, if you will, that was used to hold the horizontal stabilizer in place while we were constructing it. But these are the kinds of wood, pieces of wood that I use versus the popsicle sticks. Another thing that we want to do here, they have you fit this particular part first, then you go back to the vertical fin. One of the things I did, I don't have it right here in my pocket, but pretend this is that 6-inch machinist steel ruler that comes with the kit.
lay that across and you look for any gaps that might be underneath here. And if what you want to do is have minimal amount of gaps so that so we got a deal that's straight across, no valleys. Now they talk about in the plans to have a helper to push up from the underside to hold things in place while these things glue. Well, what works, that will work, but what works I think a little bit better, and you can do this by yourself and take your time with it, is I took on the underside of this, there's a valley, if you will, where the laminates are going to eventually go through here. I took a piece of wood, it was a 1x4, ripped it in two, maybe even a little bit smaller than that, about this length. And I had, in this particular case, though it may not look like it now, this particular side of the fuselage, for whatever reason, was lower than this one. This one, when I put my straight edge on it, it was absolutely straight, and then here it dove down. So what I did, I took this piece of wood I just talked about, lined it up in the valley, along the, it's parallel with the valley, and then I put a 2x4 right in the center of this 1x4 and pushed it up. And then to get it to the right height, I used wood shims like you would buy at a hardware store. And then when it's held in place, then you can glue it and leave the things alone until the glue dries, and you're going to have a far better fit. But you're going to have to jockey and do a few little things to get the fit absolutely right. For me, the most difficult part to jig was the vertical fin. And as you can tell, this looks a whole lot different than the part from the firewall back to where the base of the windshield is going to be. And there is, by the way, a sequence to the jigging. They want you to do that area up there from the firewall to the fuselage, and then come back and do the vertical fin. And then the third phase is at the top of the windshield, back down the spine of the fuselage. What happens here is that, or the problem that I had here, I would have, I'd try to hold it in place and tape it with some duct tape, and what would invariably happen is, say, this particular half of the vertical fin would shift and go underneath this side, or vice versa. After a while, and struggling with it for some time, what I did, I took my hot glue gun and I glued some chunks of wood along the leading edge of the vertical fin. And I let the glue set up for quite a little while, maybe 20 minutes. And then with the help of my sons, I had them, starting at the bottom, hold it together. And these are strips of wood. They're 1/4 inch thick, and I don't know, I suppose they're a couple of inches long and maybe 1 inch wide. I literally took wood screws and screwed this piece of wood into these two chunks, and that held the vertical fin tight, right where I needed it. And then where there might have been a few minor gaps, I used the duct tape to go ahead and finish the close here on the leading edge. Now, the thing here that you need to be cautioned about, these are wood screws, and you better be careful where they're going and that they are in fact going into these blocks of wood, because the last thing you need is to put a screw through this composite material. Another thing we did, up at the top, and maybe you can't see it, but the aft, I do have a C-clamp with a wooden spacer in the back side of the trailing edge here of the vertical fin. That helped keep things oriented as well. It's just a trick that, like I say, necessity is the mother of invention, and this is what worked for me to hold this leading edge tight together. These are pretty significant pieces of wood compared to the popsicle sticks the plans talk about. Again, it's a 1/4 inch thick, and I suppose this is probably 6 inches by 2 inches. I took some weights and pushed this side of the fuselage down so that it was now, in fact, lower than this side. And with this down, I could hot glue half of this chunk of wood on this side of the fuselage. After it had cured, I took the weights off, and this came up. This side of the fuselage came up, but it was not, the seam that we're looking for here was not even. So what I did, again, I took some door wedges. You can buy them at any hardware store. They're really inexpensive. And I slipped my door wedge underneath my chunks of wood, and that lowered this panel so that it was the same height as this one. These things, back in the old days when we were building very easies, long easies, and Q2s and Q200s, there was a tremendous amount of jigging that was required when fitting the canopy to the frame that you had to make. And that was a son of a gun of a job, I'll tell you what. There was nothing pleasant about it. But you did become an expert at jigging, and this is kind of a holdover that I have from those days, and it works out very, very well. Another thing we do, again, we take our little 6-inch rule and we just lay it across here at different spots to make sure that in fact it's flat. And I've done that. At this point we can take our fuselage now, flip them upside down, and press on with the next phase. The whole key, I suppose, to jigging is that you just can't be in a hurry and try to be as analytical as you can as to what will work. You'll find that whatever it is you're doing and you've struggled with it for 15 minutes, you're no further ahead than you were before, then something else needs to be tried. Oh, something that's also important to note. When I did the very first part of the jigging, where I was going from the firewall to the bottom of the windshield, where the two fuselage shells here met up, they weren't straight. When they were cut and they came out of the mold, there was no way that you could get the seam nice and tight like what we've got here. So I fashioned a sanding block and went after it, and it took very little sanding really, and all of a sudden the seam was straight on both sides and the parts fit together well. So there is some sanding that probably will have to be done. On that same note, before all of this was put together in the jig and what have you, when I had them apart, here again in the trough where the laminate is going to go, there's a 3.5-inch piece, wide piece of cloth that's going to be laminated in here, in fact 6 layers of it. All of that area has all been roughed up and then wiped clean with acetone, so that when this is flipped upside down, what have you, we don't have to do any sanding or anything that might possibly jostle the jigging that you've done. What we're looking at here is the back end of my fuselage turned upside down. I have just finished glassing the two fuselage halves together. If you look real careful, you can see the string hanging from the waterline marks, and there's a plumb bob hanging on the end of it to show if the vertical fin is twisted at all. In my particular case, when I first put the plumb bob in place, I had to push the vertical fin to the left maybe 1/8 of an inch to make it completely straight up and down. Here's a little better shot showing the clamp and the spacer holding everything in place, and if you look dead center you can see, if you look hard anyway, the plumb bob, and you can see how the string is right center of the split line. And you come on up, and right there is your waterline mark. Here you can take a look at the glassing that went on place that holds the two shells together. There's nothing really that difficult about any of it, except for, of course, the jigging of the fuselage shells together in the first place was somewhat of a challenge, but the key thing there is just to take your time and to be patient. The hardest laminate was the vertical fin, particularly at the bottom where the C-clamp is at. I think if I had it to do over again, I might have started at the bottom with maybe a 2-foot piece versus the 48-inch piece that's required, and just put it in place and maybe overlapped the other piece 3 inches onto the one that on the 24-inch piece you just put down. Just a smaller piece, particularly at the end down by the C-clamp, it's just very tight to get in there. Also, when you're glassing this piece in place, there's a real strong temptation to take that C-clamp off and get rid of the spacer so you can get in there easier with the brush. All I'm going to tell you is don't do that. To do the entire layups took me 2 complete hours. That was just a lamination now. That had nothing to do with the jigging of the fuselage and cutting the cloth. The cloth took quite a little while. Here we're looking at the front end of the airplane, and you can see that I have the firewall opening jigged pretty much in place. The hope here is that if I have it as perfect as possible, when it comes time to fitting the cowling, it won't be a disaster. Jigging is something that takes time, but the results will pay off big if it's done right. Here I use the paper template of the firewall cutout, and that's where I got the shapes that the wood needs to be. You can see a stick that kind of runs at an angle perpendicular to the 2 pieces of plywood. The reason for that is to hold them in place while the bondo is bondoing the pieces together. And then what I've done on the front side, which you can't see, is I've used little door wedges and put it between the skins and the wood that you're looking at to push them out. What I have on the periphery of the flange is the firewall cutout, and it goes around the outside. So I'm kind of pushing against the skin. Is basically a sandwich between these 2 things with door wedges to help hold everything in place. You want to hold it in place as close as you can, but like the plans say too, there's a little shrinkage that goes on with the duplication of the template that's being used. So consequently, if it's not fitting quite perfect, you don't want to get carried away with door wedges and what have you, where you actually cause some deformation of the fuselage skins. This might give you a better idea of what the heck is going on. You can see the door wedges coming out and how everything is kind of in place here. I'll kind of pan down. The idea is to get everything to fit as perfect as you can. But you can see I also have a piece of wood that is the same shape, if you will, or as close as shape can be duplicated of the firewall cutout. Here we're looking at the forward belly pan, and you can see little dabs of Bondo holding them together. Actually, this part here was extremely easy to do. It required, in essence, virtually no jigging at all. The fuselage shells, I've removed it now, but from one side to the other, the shells at the trailing edge of the belly pan, forward belly pan, had to be pulled in about 1 inch. And I've bolted or clamped down 2 C-clamps, put some safety wire between the clamps and a screwdriver between the safety wire, and just twisted it until the shells were pulled in. And once I had it in the perfect place, I just took dabs of Bondo and bondoed this forward belly pan in place. Now last night I went ahead and I put a layer of glass on the underside of the forward belly pan and the fuselage shells. This is kind of one of the first steps in getting the belly pans put in place. Tonight I'll go ahead and put the large triangular piece in place, and we'll Bondo at least one side of it. And then you can go ahead and shift the triangular pan left or right, whatever it needs to be, to make sure that your vertical fin is straight up and down. We're not going to worry too much about that at this point. We're just going to fit the triangular rear or aft belly pan in place tonight, and then we'll roll the fuselage back over right side up to do the actual checking to see if the fuselage has twisted at all. The wooden spacer you see here, of course, is to hold the fuselage apart at the right place so that it's the same width as the aft belly pan that's going to be affixed in there. You have a mark on both sides here. In other words, the right panel has one, the left panel has one. The same thing occurs up at the forward part near the firewall area. These things are very handy. You're going to hook your water line to these things to make sure that everything is level and square. And it's nice that they exist, because in the old days we builders had to find our own points and mark them, where these are precisionally put in there while they're being molded. We're looking at my Glasair right side up, and I'm panning down, and you're seeing the plumb bob as we're trying to get the vertical fin straight up and down. The boards are on the bottom here for nothing else, just to show a contrast, to see that I have drawn a string versus drawing a line like the plans call for on the ground. Now this part here was not real easy to do. Initially, the rudder was over to the right exactly a ½ inch too much from center, so I had to come back to the left. I find out from Glasair this is a common situation. Sometimes it's fixed, sometimes it isn't, but the plan here is to try to make it as perfect as possible. What I did, I took on the left side of the aft belly pan, I trimmed off a little bit of material from the aft edge forward about 32 inches, and I took off approximately 3/16 of an inch at the aft portion, which you're looking at, and then tapered it down to nothing for about 32 inches. And then when it was bonded out and put together, it pulled the vertical fin to the left, and right now I'm proud to say it is exactly straight up and down. Some of the last footage you saw was the little precision mounted dimple for the water line. What I had done there, because the dimple is white on white, it's not as easy to see. So what I did was I took a little blue magic marker and just drew around it. So in case you're wondering what that little blue gob was, what I was doing is just making it easy for myself to discern where the dimple was located. Secondly, you have seen me, and I have talked about in the past, about putting fiberglass cloth on plastic, doing the layouts. In fact, you saw me do that when I did the fuselage reinforcement points for the wings and the horizontal stabilizer. That's a very good idea. However, there are places, particularly where there are multiple compound curves that you're working with, you're going to have to go ahead and do the layup dry. The reason being is it's just a little bit easier to work with when it's dry than when it's wet, and you have a better chance of getting rid of the bubbles too when you're dealing with a multiple compound curved structure. Third, let's talk just a moment about the resins that we're using. The thing I want to stress here is that the larger your batch is going to be, say you make a batch of say 100 grams, and you mix that up, the larger the amount, the faster it's going to kick off on you or heat up. So consequently, you want to keep that in mind. Even if you mix a catalyst, say 1% or 0.75% catalyst to the resin, it can still set off on you a lot quicker than what you anticipated. So just kind of keep that in mind. What I do is I use, depending on the situation, I normally don't ever go more than 50 grams at a shot. What we're looking at here is my aft belly pan glassed into place. We want to spend a little time and talk about this for a moment or two, because you go to any Glasair fly-in, and this always makes a good war story on what a hell of a job it was to glass this thing into place, and it really doesn't have to be this way. And let me share with you some things that I learned so you won't have to struggle, or at least not nearly as much. These laminates, as I recall, are something like 108, 110 inches long each side. Now, what I did, my aft belly pan, once it was fit properly and so that my vertical fin was straight up and down as per plans, dabs of Bondo were used on both, at the seams on the exterior side here. You can't see that, but there were once little dabs of Bondo to help hold this thing into place. With that, I spent a lot of time thinking, how in the world am I going to do this? Because they talk about making this elaborate thing so you can crawl around on top of this stuff while you're glassing it, or maybe taking the airplane and setting it up on its nose and getting a ladder and standing up inside. Well, after giving it some careful consideration and talking to some fellow home builder friends of mine, putting our heads together, this is what we did. If you look at the first off, the surfaces that are going to be laminated have already been prepped. But what we did, you can, as you're looking, you can see where the hole is, where the rudder is going to go. We're looking from the front, looking back. At that hole, I did have some help. I had my son and my good friend Jim Patterson. And what was determined was, we took these layups. Remember I just gave you this little spiel about, you know, having the stuff set up on you too quick and just using 50 grams at a shot. I took these layups and laid them up on my plastic like you've seen me do in the past. This is not a multiple compound curve, and it works very, very well. However, because of the number of laminates, you don't have time. I think I'm shooting from the hip on this, so when I say it takes X number of laminates, you check me and look in the book, because I don't have the book open in front of me when I'm talking to you. But I took one layer at a time, laid it out on my plastic, and did the laminating. Then I took some duct tape and I taped the underside of the plastic, maybe, I don't know, 6 inches of it at one end of the laminate. Remember, the duct tape is on the plastic. And then I took the other end of the duct tape and I taped it to a 1x4 that was, say, 6 feet long. So with the fuselage in the position that you're looking at it, it's just resting comfortably on 2 padded sawhorses. My son and Jim Patterson were outside, aft where you're seeing, and they gave me the stick. I'm standing at this point right where one day the center belly pan is going to go. The stick came in, this 1x4, and I grabbed it, and that way I'm able to reach the end of the laminate. I pulled everything into place, and then my son and I just took the untaped the 1x4 to the plastic, and just took the plastic and flipped it over and put it into place with the laminate, of course, on the underside of the plastic. Peeled the plastic off, and that's all that we did. And we did that however many times there were laminates to do. Now, a couple of things here. My shop, as you've probably noticed in these videos, is not very elaborate, and sure as heck is not big. It's exactly 18 by 12 feet inside dimensions. But I do have, I may be short on room, but I'm big on light, and I have an excellent lighting system in this little shop. However, even so, initially, when I started to do my stippling, making sure that there was no bubbles between the laminate and the fuselage and the belly pan panels, I had to get an exterior light because it's dark back there. It's a lot darker than you think, and consequently you can't see as much as you would think you'd be able to. And so a light was retrieved, plugged in, and we went ahead and it worked fine. But you will need an exterior light. Also, that little thing that coils up looks like a snake on the right-hand side of your TV screen, that is my antenna that was put into place. You saw that earlier in the video. Do not waste your time trying to duct tape the cable to the inside of the fuselage panels. It will not stick ever. And what happens, we tried that to begin with, and the damn thing kept falling down on top of our laminate, getting in the way, particularly when as you're looking at it, the one on the left side. What would be a good idea is to take the coax and tape it with duct tape on the white semi-finished side of the shells. There it'll stick fine. But anyway, that's how I did those 2 belly pan laminates. I didn't have to make any elaborate jigs. But when laminations start to get difficult, stand back and look at it, call a few friends and figure out how in the heck am I going to do this and make this as easy on myself as possible. What we're looking at right now is the firewall. And we're going to back up a little bit. It's pretty obvious, or it should be obvious, that a lot of things have been done prior to the firewall being put into place. First off, this sheet right here when they give this to you, it is shaped almost like a large soup bowl. That's a little bit of an exaggeration, but not much. And the challenge is to get this as flat and true as possible. Before we work into getting the thing flat and true, one of the first things they do is they have you take a razor knife and make grids on it. I think they're inch square. If you look close, I think even the camera will pick up the grids. And once you've made the grids, I took this material and I used sheetrock screws and screwed it to about a 7/8 or 3/8 or excuse me 3/4 inch thick multiple ply plywood. The sheetrock screws went through the plywood up into the Rogan-cell material, and it pulled it down and it made it flat, or at least significantly improved. With that done, Q-cell is put on in 2 layers of glass. I let it set up for a couple of days in this case, unscrewed it, and flipped it over. And even though I had improved it significantly, there was still a little bit of a bow in it. And I went ahead and I did my layups, my 2 layers of, at 45 degrees that were cut, cloth on the opposite side. And then I used some 1x2s, putting duct tape underneath them so that they would not stick to the resins as they were curing, and some C-clamps, and clamped it down. And you can put a straight edge on this now, and it's real good. I'm real pleased with how it turned out. At that point, using my firewall template, I went ahead and I cut this thing to the proper size and fit it inside the front end of the airplane here. The challenge I had, and I fussed and fussed over it, and as it turns out I didn't need to, but you go ahead and you level your fuselage longitudinally, and when you put this thing in, put a level here in the center. I use a couple places, of course, to make sure that the firewall is straight up and down. Now the plans call for the firewall to be recessed 2 inches aft of this flange right here, which is the aft side of the engine cowling flange. What happened is that you go ahead and you do that. You go ahead and give it the 2-inch dimension you need here and here and here. And if you stick with that 2 inches, you put your level on here, it's not straight up and down anymore. So after fussing with the thing for several hours, I called Glasair, and you're allowed to fudge just a little bit. My final findings were the bottom of the bottom of the firewall has to be pushed in aft. Actually, it's in further aft here and more out at the top. My final dimensions were down here was 2.2 inches versus the 2 that they wanted, and I was 1.8 up here. But that was within tolerance as far as the Glasair folks said, and that's how it turned out. I've also talked to other Glasair builders, and I find that having it shoved in more at the bottom and out at the top is a very consistent, seems to be anyway, a very consistent situation. With that done, I went ahead and I Q-celled it in place. When you Q-cell, unless you're going to go ahead and glass almost immediately, you're going to want to make sure after the Q-cell dries is take a Dremel tool and get rid of all of the spuzz that maybe you weren't able to wipe up. Because whenever there's a little hump or a little tiny piece of Q-cell, you glass over that, what you have there is a spot for a bubble. So take a few extra moments, take your Dremel tool, and run around the corner and clean this thing up before you start to glass on it. Now let's talk about the glassing. They wanted, I think, a 6 inches overlap at center. So I've got my center line here, I extend it out, and start my glass, say 3 inches off to one side, and go on up around, and then the same thing over here, and the 2 pieces of glass, of course, will give you your 6 inches that you're talking about. Whenever you're glassing, again, like I said before, sit down and think about how you're going to go about this, and try to have good old Mr. Gravity working for you. Now this is not the cloth that we use, but this is by no means cut to shape here. This is just for demonstration only. But what I found, if I had it rolled up in my hand, I started over here in the corner. Again, this is dry now, not with the plastic, because we're dealing with a compound curve here. I'd roll the thing out and come on up, and that way, by the time I got to this point, you know, a good chunk of my fiberglass cloth was already gone. It was easier to handle. When I got up here to the corner, I could take my little roll that I had left. It was going to continue me on over, and I could set it on top of my fuselage, giving me both hands free to work. It worked out real well. And once that was done, I went ahead and again used my my drill here, and I went ahead and re-verified the holes where the engine mount is one day going to go. Be careful in not covering those holes up, or rather losing them, I guess is a better word. Because once the holes are already in there, you've already drilled the holes when you did your layouts and when you laid out the firewall. When I say doing the layout, I'm talking about specifically where you're going to cut out the foam on the back side. There's a lot of figuring that goes on as to where everything is going to fall on the aft side of this thing, one of which is going to be these little 1/8" pilot holes for the engine mount. Now once this thing is glassed in place, I took my drill and went to the other side and punched my hole out through the cloth. Rather, should I say, once it was glassed in place and cured, I did that, because I didn't want to lose those holes. What we're looking at here is a reinforcement that goes on the aft end of the forward belly pan. It goes total span-wise all the way across to the other side. Even the plans warn you that this is a difficult layup, and they're not kidding. It's nothing really that hard, really, if you just take your time. Because we're dealing with multiple compound curves here, it's best to do this one dry. In other words, you applied some resin to the area where the cloth goes, and then just roll the cloth out on it. What I found, if I started over in the upper corner here, say for example right about here, then took my cloth and rolled it down toward the base, and as I rolled it down, I stretched the cloth so that it would go over the back side and the forward side of this at the same time. If you go ahead and just roll this down and do one side at a time, and then think you're going to flip it over and have it fit nice and smooth without creating some problems, that's not what's going to happen. So it's best to start at the top, like here, and then roll it on down, and as you're rolling it down, you're wetting the cloth out on over to the overlap point. It was a timely layup. I was in that many hours. Here again, it's convenient to have like a bar stool to sit on. Make yourself comfortable, because you're going to be there for a while. Also, you want your fan going to help vacate the fumes from the resin. What you're looking here is a reinforcement layout that goes all the way across the back side of the firewall. This layup is very similar to the one we just talked about. The little blue lines that you may see is nothing more than the magic marker marks on the cloth I used, so I could cut the cloth out to the right shape. Something that would be of a real help to you when you're doing this reinforcement laminate that's going across the firewall, on the belly pan below it, lay out a couple of sheets of newspaper, because you're not going to be able to help from dripping some resins, and it's a lot easier just to throw the newspaper away than try to clean up the belly pan. Here we're looking at 3 of the engine support laminates. We span across and we can see a 4th one. All I'm going to say is you're going to spend a lot of time on the back side of this firewall, but when you stop and think you're going to hang anywhere from 160 to a 200 horsepower engine, probably spinning at constant speed prop, there is a good deal of laminating that goes on behind here. Hours and hours and hours of it, and you're going to spend a lot of time cutting cloth out. Each one, there's a total of 6, but each one of these little support laminates here requires 8 layers of glass on the inside, and I think 4 on the out. When I was to the point outside of the little structure there, when I was laminating the inside between the 2 little members that jut out aft, it took just about an hour for each one of them. And again, because you're dealing with compound curves, you have to do it dry. Nothing hard about it, but it takes a lot of time. I would recommend, here's something that worked out pretty well for me. If you've got the time, I would set down, like for example, I would put 1 layer of glass at the lower left, glass into place. Then I would go to this one here that's about center. The second one, put 1 layer in, go to the third, and go to the fourth. And then come right on back and start all over again. By the time you get back to the first one, it's already going to be a little tacky, and it helps having the cloth tacky when you're doing multiple layups like this. When you get the ones on the bottom done, the 4, then go ahead and take the fuselage and flip it upside down and do the upper ones. Now you can go ahead and do them standing on your head if you want to, but it's a lot easier to go ahead and flip the fuselage. Bear with me just a little bit here. We're on the bottom looking up at the opening where the windows are going to go, and you have to put a piece of foam in this area, then you go ahead and you glass it. Now the white blotches that you see is Q-cell. Now what I did, this was later going to be covered with some kind of upholstery, but there can be some irregularities in this particular area, and using a little Q-cell, smearing it on, making it flat, is going to make your upholstery one day lay down nice and smooth with no humps and bumps in it. So I just put a few blotches down. The only thing I did different here is that they have you take like a full inch of foam, as I recall, to carve the thing down to fit into this area that goes from left to right of where this laminate's located. And that you can do that, but what I ended up doing is I just got a piece of, I think, 3/4 inch or 1/2 inch foam, whatever it was, and it went a lot faster because I didn't have to sand all the extra foam out of the way. Again, when you're doing a layup like this, of course you've got the fuselage rolled over, so you've got Mr. Gravity helping you out. Here we're just looking at the top of where the windshield is going to go. There's a laminate that goes down here around the complete perimeter, both left and right, and then I think it's 2 layers of cloth. And then you come over here to the corner and you have 2 layers of cloth here that go on up and go all the way around. There's nothing magic about this. The key thing here is to put the fuselage in place so it'll make it easy for you. What we're looking at here is the 2 vertical members that's going to one day be part of the structural member for your nose landing gear. This now completes all of the laminations for your engine support points, your reinforcement bars everywhere. What we're going to do at this point, instead of going onto the tape showing you how to bolt on the nose gear and the engine mount, we're going to skip and go right straight to the header tank. The point here is I'm trying to get as much laminating done as I can while I have the summer months in my favor. And then when it gets cold, then I can go ahead and worry about doing the mechanical things. What we're looking at here is the foam cut and laid out for the header tank. You notice the one to the left says aft, the ones at the bottom say side, the top one is bottom. I found out discovered when I was building the header tanks for the Q200 to go ahead and lay and cut the foam first and then go ahead and glass it all in unison.
We have our header tank. It's all set now at this point to be Q-celled and glass into the fuselage. The thing that I did maybe a little different is the fact that I built what you see here on my workbench. I felt that that was going to be an easier way to do it than trying to work and do all of this inside the fuselage. We'll see when I go to glass this in if this was a good idea or not. As you can see, I have a little float gauge to tell me how much fuel I have in my header tank. This is made by Rochester gauges, and it can be attained through aircraft spruce. When you go ahead and you are glassing your sump in place, make sure you put a piece of plastic or something underneath this cork, or it's going to stick on you. Recently I talked to a gentleman who has built 2 Glasairs. This sending unit comes with a rubber gasket that's supposed to prevent fuel from leaking, and the 2 airplanes that he has built, he's yet to see that work, and advised me to just go ahead and mill fiber both down here by where my fingers are, and on the exterior on the sidewall, mill fiber the thing in, get good squeeze out, and then go ahead and put a layer of fiberglass over the top of it. There's nothing really difficult about building the header tank. It comes pretty well straightforward. Stoddard Hamilton has gone ahead and made the little metal inserts that already have the threads in it, where we're going to put another line here. It also comes with a finger strainer that will go in to the left side of the header tank. These things are kind of nice in that the last airplane I built, I had to chase all these things down. I had to make these by hand. It's kind of nice to have things all done for you, or at least a large part of it. Here, as you can see, we have some vents, and you might notice that they're not laminated yet. You need to have 2 layers of glass here to help hold everything in place. And what I'm going to do here is when I glass this to my firewall, I'll go ahead and utilize that laminate to cover this up at the same time. You might notice too that the aft side of the side panels here have all been hogged out for the mill fiber. Something that's very important, and maybe you know this, maybe you don't, but it's possible to orient this thing so that it reads backwards. In other words, when the cork is all the way to the top, if this thing was turned upside down, it's going to read empty. When it's down here, it's going to read full. So you want to make sure, note the orientation that I have this in, so that you won't read this backwards. When I was building my Q200, I had a similar type setup, but I was able to discover this particular phenomenon before I had glassed anything in place. So just take a look and see how this is oriented. You've got your little 2 tabs here that you can see on the outboard end, your little dot here in the middle. It takes a little while to cut, and this arm actually comes about 3 foot long. So as you can see, I've cut a lot of it off. I spent a lot of time fooling around getting this thing so that when this thing was up hitting the top of the tank, it was against the stop right here by my middle finger, and then when it was empty, it was hitting the stop here at the bottom, so I would get perfect readings on my header tank. Also, when you build your header tank, the little sump here is already provided for you by Stoddard Hamilton. As you can see, the header tank has now been glassed into place with the exception of the aft panel. There's nothing really magic about this. I think it took me 3.5 hours to cut the fabric, radius the corners, and glass it in. If you'll note, you'll see a little stud just about the end of my finger. That's going to be your grounding stud. That's something that has to be installed when you glass your transmitter into place. Also, if you'll see the vents clear in the back, you'll notice I've got duct tape around them so that when I'm glassing this corner seam, I'm not getting any epoxies or tape or anything on those threads. The next phase now at this point is to coat the inside of the tank like they say to do with a thin coat of epoxy, and then put this aft panel in, and we're done. And then from this point we go on to the rudder pedals. This is probably obvious, but you're looking at the header tank with the fuselage upside down. This is how I mounted it. Found it a lot easier to have gravity working for me than against me.
And I also put some Q-cell on the side, on the edges here where they're going to go along the fuselage. And then I put the Q-cell in place first, and then just smushed the box down on top of it and got a good squeeze out. Here in my hand is a paper template for the fabric that you're going to cut for the engine supports gussets. This particular one is one that goes in the middle. And there's a particular orientation these three tabs go in when you're doing your lamination. I found that if I took my fabric and went ahead and folded it like it's supposed to be to begin with, took it like this, and then went ahead and put it in place, this being the fabric now, that made the lamination a lot easier. It's still going to be laborious, but I found that this technique worked pretty well if you take the fabric and fold the tabs in the proper orientation. Also, on the header tank, remember the little cork that's on the end of the wire that's going to bob up and down, let us know how much fuel we have in our header tank? The last thing we do when we close the header tank in is to put on a resin-rich coating to the header tank. Now, what we have to be concerned about there is we want to make sure that the coating is totally dry. Otherwise, when we roll our airplane up right side up, the cork is going to go ahead and drop, and it's going to stick to the resin that we have put into the header tank, and how you're going to free it is beyond me. So what I have done is I've left the fuel cap off and have had a heater on the inside, or blowing warm air, if you will, on the inside of the header tank for a number of days. And as a test, I would stick your finger up in the fuel cap hole to make sure that the resin is completely dry. One other thing, when I cut the hole in the top of the fuselage for the fuel cap, I used what's referred to as a fly cutter. This is a Craftsman, a Sears Craftsman tool. It's also referred to as a circle cutter or a fly cutter. A couple of things. And what they recommend is this is to be used in a drill press, but it can be used by hand. Just be careful with it, because this thing here is your pilot hole, and then this thing here is your cutting tool, and it's spinning around pretty fast. You want to have a good hold on it. Never, under any circumstances, go ahead and set say a tape measure, and you're measuring from the pilot hole to the outside edge of your cutting knife. Go up to an instrument panel or whatever and expect the dimension to be right. Get yourself some scrap plywood, an 1/8 of an inch. Wood paneling works real well too. Do a couple of pilot holes, and then take the object that's going to fit in that hole and see what kind of fit you have. Otherwise, it can be very embarrassing to find that the hole is either, particularly if it ends up being too big. I had a friend of mine who did that to one of the sculptured Glasair instrument panels, and I think they run a little over $400 now, and he had a number of holes that he had drilled, and they were all too big. So anyway, try it first before you go ahead and think that everything is okay. Well, since we videoed last, we've completed the basic fuselage construction. This means that the rudders have now been installed, the horizontal stabilizer has been put into place, and on and on and on. What we're going to do now is go over the first thing we're going to do is take a close look at the rudder pedal assembly, and then we'll work our way aft, showing how we went about and put the horizontal stabilizer in. Putting the stabilizer in was a really exciting part of the project, because now it's really starting to look like the poster, which is, I think, a good sign. With that, we'll go ahead and we'll take a look at the rudder pedals. Once the rudder support laminates are in place, you go ahead and you make sure that the fuselage is level laterally using a water line, and that the heights here are all equal. Then you go ahead and make your bearing supports for the assembly. Now, this white material is extremely hard. Now, when you go to cut it out, make sure, I used a bandsaw with, I think it had like 20 teeth per inch. Make sure that your blade is sharp, or it won't cut it straight and true. This is extremely hard material. It will last
long after we leave this planet, I am sure. I was very impressed with the strength of this stuff. Once these are made, if you'll note, right now, of course, we've got the rudder pedals in, and if you look back here, you can see that I've got the master cylinders in for the brakes. I went ahead and mounted these up prior to the installation of the wing. I felt confident, having talked to other builders, that if I went, in my particular case, 12.5 inches, I believe it was, after the firewall, that the first tube was, or torque tube here was put in place, that would be adequate. If I was still too far away from the rudder pedal, I just put more cushion underneath me. But once these are in place, before these are here, I've got, if you'll notice, 3/16 inch wood dowel that goes through here, and same over there, just to get it level and squared. Once that part is done, a little tongue depressor will go underneath these little blocks, or underneath where they go underneath right where my finger is. The blocks are on the ends of the tube, but they are not secured to the structure at this point. The idea of the tongue depressor is to raise these things up so that the tubes aren't rubbing. Once that's done and you're satisfied with how the fit is, I use the clamp and clamp these in place and drill one hole at a time. Now the hole was already pre-drilled as far as this material was concerned. So all I had to do was get my drill bit in here and drill through this laminate. A 90-degree drill attachment is an absolute must here. In fact, I've used it different places during the construction so far, and it's a tool well worth having. I bought mine at Snap-on, it cost $60, and it's paid for itself twofold as far as I'm concerned. That's about it. These are jacked up, the ends are in place, you drill the holes, run your bolts through, and it's really nothing to it. If you take a look at the back side of the rudder pedal, you can see these little links that bolt in place. There's two here, there's two on the other side. The point I'd like to make, these things have to be lined up and critical, and the alignment is in fact critical to the operation of your brake assembly. There's a template supplied in the plans, and once you lay the template out, you cut out the 4 pieces, it comes time to drill the 3 holes that are going to be put in place. Now, what I did, and I would recommend this, is take one of them and lay out the 3 holes. In other words, decide where they go and what have you. And then when it comes time to drill the links, clamp all 4 together, line them up as perfectly as you can, and drill all the holes at the same time. That way you're guaranteed that when you bolt these things onto the rudder pedals and what have you, that all 4 are going to line up the same way. Now comes the exciting part, the installation of the horizontal stabilizer. There's nothing more exciting than to see the parts come off the stands and be put into place on the airplane to give you a sense of accomplishment, and things are moving along like they should. Step 1 of doing this is you get waterline 100 here level. In other words, the fuselage has to be level longitudinally. If you'll note, at the end of my screwdriver, there's actually a magic marker mark that verifies where waterline 100 is, and you can put a level here if you want to after you've done the waterline trick. The next thing they have you do is, where the horizontal stabilizer goes through, there's some scribe lines that are already in place in the fuselage shells. You simply take your little hand saber saw or jigsaw, cut that out. Now the next part, from that point there, I would go ahead and try and mount your horizontal stabilizer. What happens here is some interesting things. There's a number of different dimensions that you have to do on this thing so that it's mounted the way the plans call for it. For example, you're supposed to have, I believe, 6.4 inches from the water line to the center of the leading edge. And the same thing, the middle of the spar on the horizontal stabilizer and the water line underneath here is supposed to be the same dimension. Now, after I cut my scribe marks out, what we decided we had to do was literally raise this thing upward, I'm guessing a full 1/8 of an inch, maybe a little bit more, to meet this particular dimension requirement. Now, what the plans have you do is, once the hole is cut out, they tell you to go ahead and make this little tool that goes in your electric drill. It's bent at 90 degrees
let's say I think a quarter of an inch long. And then with that tool, you hog out the foam around the perimeter of the cutout. Well, the problem is, if this has to be raised up an eighth or more inch, you are cutting in, or diminishing, if you will, the area where you've hogged out the foam. So I would hog out the foam after the fact. I also had a fellow Glasair builder give me a hand, Blaine Snow, who was building an RG model. He was good enough to come on over. And an extra set of hands is a very good idea. And being as critical as this is, to be right, another set of eyeballs from another builder is a very good idea. Once this was cut out, and it fit properly, you're going to have to, I'll tell you right now, no matter what you do, there's a strong possibility you're going to have to make this original cutout larger than what the scribe marks are. The scribe marks get you started, and that's about it. But that's better than nothing. A lot better than nothing. What we did here, where my hand is, and you're going to see snapshots of this at a later in this program that'll help you. But right about here, there's a 2x4 that I hot glued to this fiberglass. And then I had a stand that went to the floor and came up and clamped on to the 2x4. So I could adjust my horizontal stabilizer up and down as I needed. The key here, I would suppose, in fitting this is not to be in a hurry. Just take your time. It took us a number of hours, I don't know, I'd say probably 2 hours to get this thing fit properly and have all the dimensions lined up. Also in the plans, I talk about using popsicle sticks to shim the horizontal stabilizer with the vertical fin. Instead of using popsicle sticks, I found out that the plain old door wedges work far superior. Being tapered and cut, you could go ahead and tweak this thing a 16th or whatever you needed to do. But there are a number of dimensions, like I say, that have to be accomplished. For example, you go from this point to your waterline nipple to make sure that the horizontal stabilizer is not cocked. The other thing we'll do here is measure. You can't see it, but there is a hinge point for the elevator, and I measured from the inboard side of the elevator to where it touched the vertical fin to make sure that the dimension was the same. Once this is secured, we go ahead and we put in, I believe they're called secured laminates, where you're going to put a total of 4 single layers that are going to go inside the vertical fin and lap onto the horizontal stabilizer. It's kind of a tight fit in here, and I did have to use a half-inch dowel, about 2 feet long, maybe a little less, with an acid brush on it, or not an acid brush, but your your 1-inch brush that you get from Stoddard Hamilton in the kit, and laid it out. Now, for this particular technique, I went ahead and wet the cloth out on a piece of plastic like you've seen me do before, laid it in place, got rid of the bubbles, and then peeled the plastic off, and that's all there was to it. Here are the first 2 bulkheads that you're going to put into the fuselage once you've got the laminates done between the vertical fin and the horizontal stabilizer. There's nothing really magic here about doing this. What I found worked real well is just take your time cutting and fitting. Oh, there was one thing. The top bulkhead, and I don't think you can see it here, bear with me a moment, but as you can see, that does go up into the vertical fin. It's kind of like an upside down Y. What I found was the template was too small for that, and I had to add a good full 1/4 inch to the sides to make it big enough so it to fit where it's supposed to go. So when you do that particular one, you might want to make your bulkhead a little bit bigger to start with a template. The plans tell you to go ahead to make it easier. You can roll the fuselage upside down to laminate way up inside the vertical fin, but I found just crawling inside the fuselage and reaching up there with my arm worked well for me. In the forefront here you can see the coaxial cable for both the comm and the nav antennas. But if you look, you can see the aft top bulkhead glassed in place on top of the horizontal stabilizer. You can also see the coax cable running down the right side of the vertical fin. There's nothing magic about putting these things in place. The templates were real close to the right size. One thing I did to help myself, I just glassed the aft side and left it that way until I had it finally fit. I thought that the laminates on the back side made it stiff enough so it would go in straight up and down, and yet it was a lot easier to cut and fit if I was only going through the one side's worth of laminates versus trying to do both. Here we're looking at the bottom of the fuselage here with the bulkhead in place. You'll notice I still have my dimension here in place at the bottom, which is supposed to be, what is it, 3.5 inches or whatever it is wide across there. And another thing that I didn't mention that you may see later is the fact that you have a straight edge clamp to the right side of the vertical fin to make sure that when all these laminates are going in, you still have a the vertical fin on the right side is still straight up and down. That will allow you to install the rudder with minimal problems. Is the header tank in place with the two sides in the glassed and in position. Remember, the aft panel goes in last, and what I've got here, it's being gooped into place, and I've got a stick there propped against the fuselage holding that panel in place. Here the rudder support laminates are checked for levelness with the fuselage level laterally. This is the next phase of the rudder installation. You notice the 3/16 inch stick that go through both the left and right sides for the rudder pedals for one-day set. These are the connecting links that go between the rudder pedal itself and the master cylinders. There's 4 of them. It's very, very important that when you drill the holes that they are stacked on top of each other and drilled simultaneously. I'm drilling the mounting holes for the links so that they can be attached to the rudder pedal. There's a little bit of finagling going on there. I've got a couple of clamps and things in place to make sure that the holes are supposed to, or the link is supposed to go where it's supposed to go. Here's a side shot that shows the rudder's in place, everything's bolted where it's supposed to go, and you can see the master cylinders. Here's a forward shot of the rudder pedals in place. We're drilling the pivotal holes for the rudder. This is something that has to be done accurately. If you'll note, there is a stick being used that we had drilled the drill bit through first over here to your right, and we're using that stick to help align the through hole where it's going to go through into the other flange. Just a little trick that works real well. One of the first steps in mounting the horizontal stabilizer is cutting out where the scribe lines are. We found that using a magic marker helped highlight the scribe marks. Once the material has been moved, we're using our special tool that's removing the foam between the inboard and outboard skins. As I mentioned before, I would do this step after I had the horizontal stabilizer installed, or excuse me, fit. Here my son Jared and Blaine Snow are using a water line to level the fuselage laterally. The horizontal stabilizer has been put in place, and again Blaine and Jared are using a water line to make sure that it's not tilted up and down. You'll note by Jared's right side a clamp and a stand used so that we can tweak that particular end of the horizontal stabilizer up or down. This is a detailed shot of the stand that was used for what I've just explained. A tape measure is being used from the mid waterline dot and a fixed point on the horizontal stabilizer to make sure that we have an equal distance on both the right and left sides, showing that the stabilizer is not canted. Blaine is double checking the dimension from the water line. You can see the magic marker line represents the water line and the midpoint of the leading edge on the horizontal stabilizer. I believe that dimension is supposed to be 6.4 inches. The same is true in the aft. Blaine is measuring from the midpoint of the spar on the horizontal stabilizer and the waterline mark. Same dimension as the leading edge, of course. Blaine is verifying the dimension from the trailing edge of the horizontal stabilizer to the trailing edge of the vertical fin. The mask door wedges are helping keep the horizontal stabilizer at bay as we go ahead and put the Q-cell in place. If you look too, you can see that the right side of the vertical fin has a straight edge. I'm using my level right there and it's clamped into place. Q-cell is dried and I have put my first, I put 2 layers of laminate right there where the screwdriver is. It goes around the perimeter of the horizontal stabilizer. The masking tape there is in place to keep your laminate contained where it's supposed to go. Yours truly is laminating the top bulkhead, the top forward bulkhead in place. I just laid on my back and reached up there with my arm. It worked real well. I couldn't get Blaine to do that for me, and Jared was too small. Actually, I thought the layup went very smooth. Both forward bulkheads have been laminated and are now in place. You can see the antenna coax coming forward. Here's looking up the back end of the vertical fin shows the 2 bulkheads that you've just seen previously. Just another view of it. I made a paper template for the cutouts, both for the top and bottom aft bulkheads, and I found the templates to be a real asset.
What you've seen so far represents 105 hours of labor to do the fuselage. Nothing about it has been overly difficult, and if anything, it's been a lot of fun. The exciting thing about composite construction is that at the early stages of construction, you see the results of your work, which really helps the builder stay motivated and excited about his project. This is very important if we hope to see these things fly. With that, I wish you the best at laminating and whatever all else needs to be done to complete these airplanes. If you have any builder questions, the people at Stoddard Hamilton stand at the ready to assist you, and I wish you the very best. I'm looking forward to getting this thing done and using it for what it was meant for, which is long, fast cross-country trips. And with that, I wish you the best. Good night now.